In this video, we're going to learn how to solve a system of equations using elimination. And just like the substitution video, this is going to follow a series of steps, and as long as you are familiar with those steps and know how they work, you will be able to solve any system of equations using the elimination method. So let's look at our first example. We have d plus t is equal to 3, and 2d plus 3t is equal to 10. I'm going to label these as equation 1 and equation 2, just so we can refer back to them. Now our first step is, if necessary, multiply each equation by a constant so that the coefficients of one of the variables will add up to 0. If we look at our two equations, what this is asking us to do is make it so that the coefficient of one of the variables is equivalent to the coefficient in the other equation. So for example, if I have a d here and a 2d there, I would multiply the first equation by 2 in order to get a 2d in both equations. Similarly, I have a t here and a 3t here. If I wanted those to match, I could multiply the first equation by 3. So let's look at this and how this works in practice. I'm going to choose to multiply the first equation by 2. So I'm going to take equation 1 and I'm going to multiply it by 2, giving me 2d plus 2t is equal to 6. So every term in equation 1 got multiplied by 2 in order to give me that equation. The reason I want to do this is for our next step to work. So if I rewrite equation 1 here, which is 2d plus 2t is equal to 6, and then I write equation 2 under, which is 2d plus 3t is equal to 10, I can now subtract these two equations and get rid of my d's. This will just end up being 0, which is exactly what I want. Then I have 2t minus 3t, which will give us a negative t. And I have 6 minus 10, which will give us a negative 4. So now we have one equation with one unknown that is easy to solve for. So we have negative t is equal to negative 4, and I'm just going to divide both sides by negative 1, giving me t is equal to 4. So we solve for variable t. Now we can take that and substitute it back into the original equation, either one. So d plus t is equal to 3. Let's choose that equation. We have d plus t is equal to 3. We know that t is equal to 4, so d plus 4 is equal to 3. Subtract 4 from both sides, giving us d is equal to negative 1. So in terms of a solution for this one, we know that t is equal to 4 and d is equal to negative 1. Next question. So in this example, equation 1 is 4x plus y is equal to 2, and equation 2 is 3x minus 4y is equal to 30. Looking at these two equations, I know that since there's no coefficient in front of the y, meaning the coefficient is 1, it'll be easier to multiply this y by 4 so that the coefficient will be equal to the coefficient of equation 2. So I'm going to take all of equation 1 and I'm going to multiply the whole thing by 4, giving me 16x plus 4y is equal to 8. Now I'm going to write these two equations, equation 1 on top of equation 2. And I'm going to ask myself, should we be adding these equations or should we be subtracting them? Since the signs in front of the y are opposite, we are going to add these equations together. Adding them together, we get 16x plus 3x, which gives us a 19x. We have positive 4y plus negative 4y, which will give us a 0, exactly what we want. And then we have 8 plus 30, which gives us a 38. Then we can take that equation and solve it for the remaining variable. So we have 19x is equal to 38, and we can divide both sides by 19 to give you an x is equal to 2. After that, we take the x is equal to 2 and we plug it into either of these equations. I'm going to choose the 4x plus y is equal to 2. So we know that equation 1 was 4x plus y is equal to 2, and I'm going to plug x equals 2 into here to get 4 times 2 plus y is equal to 2. 8 plus y is equal to 2. Subtract 8 from both sides, and that gives us y is equal to negative 6. So in this case, our point of intersection, or our solution, is x is equal to 2, y is equal to negative 6.